Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind, and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the oldest and most profound questions ever asked beneath the stars. Does space ever end? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the deep fabric of space together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. South Space. It's such a small word, isn't it? Just 5 letters, and yet inside that short word lives everything. Every star, every galaxy, every dusty rock and icy comet, every breath you've ever taken, and every dream ever whispered in a quiet room like this one. They've all happened inside space. But what is it really? Maybe you've asked yourself during a silent night, looking up at a sky so full it feels like it might spill over. Does it go on forever? Is there a wall out there, a curtain, a ledge where it all just stops? Or does it stretch endlessly, like a thought with no conclusion, like a song that never quite ends, just fading into stillness? You're not alone in wondering. In fact, humans have been asking this question for as long as they've had the word where. Before telescopes, before maps, even before the concept of zero, people looked up and wondered what might lie beyond the stars. And tonight, we're going to walk that gentle path of curiosity together, not racing for answers, but strolling through them like a soft twilight garden. To begin, it might help to ask not where does space end, but what is space to begin with? That might sound simple, but it's a question that has quietly unravelled the minds of physicists, poets, and stargazers for centuries. You might imagine space as a big empty box, a container that holds things, like putting apples in a basket or planets in a room. But that image, while comforting, turns out to be a little misleading. Because space isn't just a background. It's not a blank canvas that everything else gets painted onto. It's part of the painting itself. When Albert Einstein came along in the early 20th century, he gave us a new way to understand space. He said it wasn't just emptiness, it was connected to time, forming a 4-dimensional fabric called space-time. In Einstein's view, massive objects like stars and planets don't just float in space, they bend it, they press down into the cosmic mattress, warping the geometry around them. Imagine placing a heavy ball on a trampoline. The surface sags. Now, if you roll a smaller ball nearby, it curves toward the heavy one. Not because the big ball is pulling it, but because the surface itself is bent. That's gravity, not as a force pulling things together, but as the gentle slope of space telling matter how to move. So already, we're far from empty. Space can curve, it can stretch, it can ripple, like a pond after a pebble drops. And if space can do all that, is it really just nothing? Even at the smallest scales, the quantum world, space refuses to stay still. Scientists have discovered that even the emptiest vacuum, the most stripped-down version of space, is humming with tiny fluctuations. Virtual particles blink in and out of existence, like fireflies in a field you can't quite see. This constant jittering, called quantum vacuum energy, means that even nothing is something. Even silence has its own quiet song. All of this begins to paint a different picture of space. It's not a flat floor we stand on, or a shell we move inside. It's an active participant in the story of the universe. A presence, not an absence. A shape, not a shadow. And this is where the question of edges gets complicated. If space is like a fabric, and it stretches, then what's beyond the fabric? Is there a wall, a gap, a place where the weave unravels? Or could it be that the question itself is a bit off? Like asking, what's north of the North Pole? What if space doesn't have an edge? Because it doesn't need one. Tonight, we won't try to force a final answer. Instead, we'll explore the ideas, the clues, the shapes and boundaries, both real and imagined, that have emerged from centuries of observation and thought. We'll look at the limits of what we can see, the shape of the cosmos, and even the tantalizing whispers of other universes just out of reach. Along the way, we'll use metaphors, everyday examples and quiet analogies to make the journey smooth and soft. Like imagining bread dough rising in the oven, or fog rolling over a still lake, or the hush of a museum filled with light from long ago. By the end, we may not reach the edge of space, but we'll arrive somewhere just as valuable, a place where wonder is welcome, and the absence of answers feels a little like peace. So take another slow breath. Let your shoulders soften. Outside your window, the night sky is stretching quietly in all directions, and right here, in this little corner of the universe, we're about to begin. If you close your eyes and picture space, you might imagine it as something dark and still. A vast, quiet emptiness stretching in all directions, interrupted only by the occasional dot of light. A star, a galaxy, a wandering comet. You wouldn't be alone in thinking that way. For centuries, people imagined the universe as a kind of giant container, a void that simply held things, planets, stars, light, time, a nothingness that hosted everything. But that picture, while intuitive, turns out to be quietly wrong. Tonight, let's gently unravel that idea together, because space, despite all appearances, is not empty. It is not passive. It is not even still. Space is a dynamic, flexible, and surprisingly alive part of reality. It bends, it stretches, it vibrates, even when you're not looking. It is less like a room, and more like the floorboards, the walls, the wind that stirs the curtains, and the silence between your steps. To understand this, we have to look back a little more than a century, to a mind that imagined something radically new. Albert Einstein, with his theory of general relativity, changed the way we think about space forever. Before him, Isaac Newton had described space as a kind of invisible grid, a blank, infinite stage on which the drama of the cosmos played out. Masses moved, forces pulled, and everything happened within space, but not because of it. Einstein gently shifted that idea. He suggested that space itself wasn't just a stage, it was an actor, a character in the story. He gave us the idea of space-time, a woven fabric that includes both the three familiar dimensions of space and the strange, flowing dimension of time. And more than that, he said that space-time could curve. Imagine a soft, flexible sheet stretched out in all directions. Now place something heavy in the centre, a bowling ball perhaps. The sheet dips and curves around it. That's what a massive object like a star or planet does to space-time. It deforms it. And when another object, say a planet, passes nearby, it follows the curve. It moves along a path that looks like a traction, but really it's just taking the straightest route through a space that has been gently bent. This idea, gravity as curvature, may sound abstract, but it gives us a beautiful and surprisingly intuitive picture of how the universe works. No invisible tethers, no forces reaching through the void, just geometry, just shape, just space softly folding around the presence of energy. And this space is not uniform. Where there's more mass, the fabric curves more. Where there's emptiness, it stretches flatter. In a way, space behaves a bit like memory foam. It molds to what's there, it remembers, it holds the imprint. But what about where there's nothing? What happens to space where there's no star, no planet, not even a drifting atom? This brings us to something even stranger, because at the smaller scales, At the quantum level, space still refuses to sit. Still, even in regions we call vacuum, where all the particles have been removed. Where no light passes and no heat lingers, space is buzzing. Quantum physics tells us that what we think of as empty is never truly silent. Instead, it's filled with jittery, restless fluctuations. Tiny particles and antiparticles pop in and out of existence, like momentary whispers that vanish before they are ever fully spoken. These are known as virtual particles, and while they're invisible to us, their effects can be measured. They create what we call vacuum energy, or zero-point energy, the idea that even nothing has energy, simply because the uncertainty of the quantum world won't allow absolute stillness. The rules of quantum mechanics say, if you know exactly where nothing is, you can't know exactly how much energy it has, and so fluctuations appear like static on an old radio dial. In this sense, space is never truly empty. Even the deepest void between galaxies hums with a quiet tension, a possibility, a potential that never quite resolves. It's like an ocean beneath a perfectly calm surface, hiding gentle waves too small for the eye to see. This might sound purely theoretical, but it has real consequences. That vacuum energy, it contributes to what we now believe is causing the accelerated expansion of the universe. It's part of what we call dark energy, a force so faint, so diffuse, and so persistent that it's slowly pushing galaxies apart at an ever-increasing pace. It's the soft breath behind the growing stretch of space itself. So, if you ever find yourself imagining space as a cold, empty silence, you might try thinking of it instead as a living quilt, one that swells and folds and shivers even when it seems still, one that responds to everything it touches, stars, light, atoms, even you. Because space doesn't just hold matter and energy, it interacts with them, it changes because of them, and in turn it changes them too. It is not the nothing between things, it is one of the things. And perhaps, in some ways, it is everything. The vast, unseen thread that stitches the universe into one soft, ever-changing whole. Now that we've gently settled into the idea that space is not empty, that it bends, curves, and quietly trembles even when we think it's still, it's time to add a new movement to that cosmic dance, stretching. Because space doesn't just sit there, beautifully shaped around stars and galaxies. It grows, it changes, it expands, and it's been doing so since the very beginning. But what does it really mean to say that space is expanding? It's a phrase you may have heard, maybe in a science documentary or on the back of a textbook, and it can conjure some strange images. You might picture an explosion, the Big Bang, flinging galaxies outward into some empty background, like fireworks exploding into a night sky. That idea isn't totally wrong in spirit, but it needs a gentle adjustment. Because what's expanding isn't matter through space, it's space itself. Let's picture something simple. Imagine a piece of dough resting on a wooden table. You sprinkle it with raisins, just a few, spaced randomly across the surface. Now imagine the dough rising slowly as yeast does its quiet work. The raisins don't move on their own. They're not rushing outward like bugs scattering across a floor. Instead, the dough between them is expanding. The space they sit in is stretching. And as a result, every raisin sees the others getting farther away, even though they're all just sitting still, being carried by the fabric of dough that's inflating underneath. That, in soft and homely terms, is what our universe is doing. The first to truly notice this expansion was Edwin Hubble, back in the 1920s. By observing distant galaxies and measuring the light coming from them, he made a quiet discovery that would echo through all of modern cosmology. He found that the light from faraway galaxies was redshifted, meaning its wavelengths had been stretched, like taffy being pulled, like a violin string loosening its pitch. And not only that, The farther away a galaxy was, the more its light had been stretched. This suggested that space itself was expanding, and the light was being carried along for the ride. The redshift wasn't because galaxies were flying through space like bullets. It was because the fabric of space between us and them had grown, and the light travelling through it had lengthened along the way. This changes how we think about distance. In an ordinary world, you measure how far something is by how long it would take to walk there, or how many steps it would take in a straight line. But in an expanding universe, the path itself changes as you move. It's as if the hallway keeps stretching while you're walking down it. The finish line moves not because you're slow, but because the floor beneath your feet is stretching, invisibly and gently, beneath each step. This expansion is not just a thing of the past, it's still happening now. Every second, the space between distant galaxies grows a little wider, not in a dramatic way that you'd notice if you stepped outside to look up at the stars, but in a way that matters, especially over vast distances and time. The universe is not only growing, it's growing faster than it used to. A mysterious force, which scientists call dark energy, seems to be pushing space apart with increasing speed. The raisins in the dough are drifting faster and faster, not because of some sudden panic, but because the dough itself is rising more eagerly than before. This brings us to a strange, dreamlike idea. If space can stretch, and if that stretching can accelerate, then there are galaxies so far away and receding so quickly that their light will never reach us, even if we waited forever. Because the space between us and them is growing faster than light can travel to close the gap. It's not that those galaxies are breaking some cosmic speed limit. It's just that the road between us is getting longer faster than even the fastest thing in the universe can run. Imagine trying to reach someone on the far side of a lake, but the lake keeps expanding faster than your boat can row. No matter how hard you try, you'll never arrive. That's the quiet heartbreak of expansion. The deeper we look, the more we find. But the more we understand, the more we realise how much is slipping beyond our grasp. Still, there's something oddly comforting about it too. The expansion of space isn't violent, it isn't loud. It's not like tearing or breaking or cracking. It's soft, gentle, like a breath you didn't know you were holding, like mist drifting apart over a field in the morning, like the slow, imperceptible way shadows lengthen at dusk. It doesn't require an outside to expand into. There is no container holding space. It expands itself. It makes room by being. It is, in a very quiet way, its own answer. This is one of the hardest things to grasp. Our minds are built for rooms, for boxes, for things that fit inside other things. But the universe isn't a thing in space. It is space. And when it grows, it doesn't move into anything. There is no edge it's pushing against, no wall to break through, just more of itself, unfolding into more of itself. So the next time you hear the phrase, the universe is expanding, you can think of that dough in the oven, the raisins spreading out in silence, unaware that the space between them is shifting. You can think of light stretching on its journey through the cosmos like a memory pulled thin by time. You can think of the stars above your head, not just shining but slowly, invisibly, being carried away by the fabric of everything growing a little larger. Space is not only not empty, it's not even still. It breathes. Now that we've stepped gently into the idea of space as something that stretches, something that expands not outward into some other place, but outward into itself, like breath-filling lungs, or ink swirling quietly through water, it's time to ask a deeper question. One that might sound deceptively simple, like something a child would ask while staring up at a night sky dotted with stars. If space is stretching, what's it stretching into? And if it's stretching forever, is it infinite? Or is it somehow bounded? A great cosmic bubble, vast and enclosed? Does space, like the rooms we live in or the fields we wander, have walls? Does it have an edge? To think clearly about this, we may need to step away from the images we instinctively carry. We often picture the universe as a kind of enormous sphere, a balloon of stars and galaxies floating in some larger void, a container, a shell. But that image, while helpful in some ways, introduces assumptions that don't match what we know or what we suspect about how space truly works. Let's start with something more familiar. Picture the surface of the Earth. Not a map, not a globe you spin on a desk, but the Earth itself as a lived experience. You can walk in any direction. East, west, north, south. If you keep walking long enough, imagining for the moment that oceans don't stop you, you will eventually return to the place you started, even though you never hit a wall or a cliff or an edge where Earth runs out. The surface of the Earth is finite, but it's also unbounded. It loops. It contains itself. You can travel across it forever without ever encountering a place where it ends. Now take that image of a curved, closed surface and gently add a dimension. If the surface of a two-dimensional world can curve into a sphere in three-dimensional space, might our three-dimensional universe curve in a similar way into a fourth spatial dimension? We don't mean time, that's something else. But a hypothetical dimension of space we can't see or move through. In this view, our universe could be finite yet unbounded, like the surface of the Earth, but in 3 dimensions rather than 2. This is not just abstract wordplay. It's a serious and ongoing question in cosmology. Could our space be wrapped, so to speak? Could you, in theory, travel in a straight line through space for long enough and eventually end up where you started, just like circling the Earth? In that case, space wouldn't have an edge or a wall. It wouldn't need to. It would be complete within itself, without requiring anything outside it to contain it. And yet, it could still be finite. Not infinite in size, but also not limited by any kind of hard boundary. This is the quiet strangeness of curvature, the idea that something can be both enclosed and edgeless, that you can live inside a world with no walls and still find yourself in a space that gently loops back on itself, a soft geometry, endlessly traversable, yet perfectly whole. Of course, we don't yet know for sure whether the universe is curved in this way. Current measurements suggest that it is, at least on large scales, very nearly flat, meaning that space doesn't seem to curve noticeably in any direction. But flat doesn't mean infinite. It just means that the rules of geometry behave in ways we're used to. Parallel lines don't converge. Triangles add up the way we expect. But that flatness could extend forever, or it could be wrapped in a subtle loop so large we haven't detected it yet. To help imagine this, think of those old video games where walking off the right side of the screen brings your character back on the left, or a mirror maze where each corridor seems to repeat endlessly, but the reality is tightly bounded by clever geometry. Or think of a hallway in a dream, where every turn feels new, yet somehow familiar, as though you've been circling a space too vast to grasp, and yet too intimate to truly leave. This brings us to an important emotional shift. When we ask, does the universe have an edge? We're not just asking a technical question. We're reaching for a feeling. The feeling of being contained, of being able to point toward a boundary. We're wondering, is this place we live in open or closed? Can it be measured? Can it be mapped? But maybe it's more like a home without walls. A place not bounded by fences but by patterns. A space that continues, not because it's infinite in the way numbers are, but because it flows smoothly in all directions, without corners, without edges, without an outside. If the universe is finite and unbounded, then asking what's beyond it may be like asking what's north of the North Pole. It's a question that feels natural but dissolves when you understand the shape of what you're asking about. This isn't meant to frustrate, it's meant to soothe. Because the absence of walls isn't a threat, it's an invitation. It means that the cosmos may not be trapped inside anything. It may simply be itself, self-contained, self-shaped, whole. So, whether the universe is truly infinite or just unimaginably vast but ultimately bounded, it may not matter all that much in our quiet quest for understanding. What matters is that there may be no place where it stops, no sign that says, "Here the stars end." No cliff at the edge of existence, just space, wrapping, stretching, humming, whispering. A home in the deepest sense. Not made of bricks, not fenced by matter, but gently bound by its own rules. And wherever you are within it, whether near a familiar star or drifting between galaxies, you are always inside, always held. There is perhaps no outside to this story, and that is its most comforting truth. Take a moment now and imagine a glowing sphere around you, vast, quiet, and softly pulsing with ancient light. It doesn't shimmer and it doesn't spin, but it's there, invisible, perfectly centered on you, wherever you are. This is your personal universe, a part of the cosmos that you can see, not because you are special, but because of light, distance, and time. It's a humbling thought. When we speak of the universe, as we often picture the whole thing, everything that exists. But in truth, when we look out into space, we're only ever seeing a tiny portion of it. A layered shell of visibility carved not by walls or clouds or cosmic dust, but by the simple fact that light travels at a limited speed. It takes time to reach us, and the universe, as vast and ancient as it is, has only had so much time to send that light our way. Since the beginning of everything, what we call the Big Bang, about 13.8 billion years have passed. You might imagine that means we can see 13.8 billion light years in every direction. But space has been expanding during that time, so the most distant light that has reached us actually comes from galaxies that are now much farther away, about 46.5 billion light years. That's the radius of your observable universe, a vast bubble of possibility, drawn not in kilometres or miles, but in the memory of light. And here's the strange, beautiful twist. That bubble is centred on you. Not because the universe revolves around you, but because light always travels toward a point, and you are at that point right now. If you moved to the other side of the galaxy, or stepped into another solar system, your observable universe would shift with you. It would still be centred on wherever you were standing. Every conscious being, every speck of awareness floating in the dark, has its own spherical view of the cosmos, personal, unique, and slightly different from everyone else's. We tend to think of the universe as one grand, shared view. But in this way, it's more like a collection of overlapping lenses, each one tied to a point in space and time. Your night sky, the constellations you see, the far-off galaxies your telescope might reveal. All of that is shaped by where you are and when you are. In a different place, at a different moment, the stars would arrange themselves into a new story. And yet, all of these personal views are still part of the same whole. Just as many windows can look out on the same landscape, each with its own angle and frame, each observer in the cosmos sees a slightly different version of reality. None are wrong, all are limited, and somehow that limitation feels comforting. You don't need to grasp the infinite all at once. You just need to hold the part that's yours. Let's picture it again. That sphere. 46 billion light years in all directions. Inside it, countless galaxies. Clusters of stars so distant their light has travelled since before our planet even formed. Quasars shining like beacons at the edge of time. Nebulas blooming in slow motion. The pale red arcs of galaxies stretched by the curvature of gravity itself. It's all there. An immense silent cathedral of light, waiting to be seen, and always arriving late. Because that's the second truth hidden in this idea of a personal universe. What you're seeing is not what is. It's what was. Every glance you cast into the night sky is a look into the past. The moon, when you see it, is as it was 1¼ seconds ago. The sun, about 8 minutes. The nearest star, over 4 years. And the most distant galaxies in your observable sphere, you see them not as they are, but as they were more than 13 billion years ago. Long before Earth, long before our solar system, long before anything that feels familiar. And yet their light touches you now. That light has travelled across a universe that has been growing, stretching, cooling, changing. It has passed by stars that no longer exist, through clouds that have become planets, past galaxies that have since merged or faded. And still it arrives, soft, ancient, delicate. A message written before there were eyes to read it. This is the quiet power of light. It doesn't just show us space, it shows us time. It turns the cosmos into a layered memory, unfolding outward in shells of increasing antiquity. The farther we look, the deeper into history we fall. The edge of the observable universe isn't a border of space, it's a border of time. And beyond that border, more universe, almost certainly. Galaxies that exist, but whose light hasn't reached us yet, and perhaps never will. We know they're out there not because we can see them, but because the laws of physics suggest continuity. The universe didn't stop just because our vision does. And so we live inside a kind of visible cocoon, woven from light and time and silence. A bubble that isn't fixed, but grows slowly as more light has time to arrive. Every year the edge expands a little, not because the universe is growing, though it is, but because more of it is coming into view. Like watching the sun rise slowly over a distant landscape, revealing hills and valleys you didn't know were there. It's a beautiful way to think about what it means to exist, to be here, now, with a personal sphere of awareness expanding softly around you. You don't need to chase the stars, their light is already on its way, some of it already older than any memory, some of it still years or millennia from arriving, and all of it yours to receive. So tonight, as you look up, remember, the sky you see is not the sky as it is the sky as it was, a time machine built from photons, a memory carved in speed and distance, a gentle gift from faraway things, arriving just when you're ready to see them. Now that we've settled into the idea of a personal universe, a soft bubble of visibility carved by light and time, it's time to ask a harder, quieter question. One that doesn't just reshape how we look outward, but how we come to terms with what lies beyond our reach. What happens to the galaxies outside that glowing sphere? Not the ones we haven't seen yet, but the ones we may never see. It's tempting to think that everything in the universe is, at least in principle, visible, that if we just had a stronger telescope, or waited long enough, or looked from the right angle, we could eventually see everything there is. But the reality whispered to us by cosmology is gentler and stranger. There are galaxies whose light will never reach us, not in 1,000 years, not in 1 billion, not even if we waited until the end of time itself. They are already too far in the only way that matters, not in miles or kilometres, but in expansion. Here's the quiet truth. Space doesn't just stretch, it stretches faster the farther you go. This isn't acceleration in the way a car speeds up on a highway. It's more like a calm inflation of the fabric itself. The further two galaxies are from each other, the more space there is between them, and the more that space can grow. Eventually, the expansion becomes so strong that the distance between two objects increases faster than light can bridge the gap. At first, this sounds like a violation of the universe's own rules. We're told, over and over, that nothing moves faster than light. But here's the subtlety. That rule applies to objects moving through space, not to space itself. Space, as a fabric, isn't bound by that speed limit. It doesn't move, it grows. And that growth, over vast distances can outpace even the fastest traveller, which means there are galaxies so far away and receding so quickly that no light they send out today, or ever again, will reach us. They are not just unseen, they are unseeable, lost not to darkness, but to distance itself. And the numbers are quietly staggering. Billions of galaxies have already crossed that threshold. Whole swathes of the cosmos, full of stars and planets and possibilities, are receding into a future where we will never know they existed. If you could pause the universe right now and look beyond the edge of the observable bubble, you'd see light still on its way, still struggling to reach us. But wait too long, and even that light will fall short. The path stretches beneath it. The goal slips away. It's like running towards someone on an escalator moving in the opposite direction. If the stairs accelerate faster than your feet can carry you, the distance grows endlessly, no matter how hard you try. Except in this case, there is no platform waiting at the end. Just space, growing more of itself. And yet, those galaxies are still out there. This is one of the quiet heartbreaks of cosmology. The knowledge that the universe is not only expanding, but expanding apart. That over time, the sky itself will grow emptier, not because stars are dying or galaxies are vanishing, but because they are drifting too far to be seen. The light they shed will never find us. Their presence will remain real but unknowable. We'll be surrounded by things we'll never meet, and still, there is beauty in this farewell. Because when something becomes unreachable, it doesn't cease to exist. It leaves behind a trace, a memory, a whisper. The galaxies that are slipping away sent out light long ago. Some of that light is reaching us now, soft, red-shifted, stretched by expansion into longer, cooler wavelengths. Their messages arrive like postcards from a younger time. By the time we receive them, the senders have already disappeared over the horizon. But for a brief moment, we are connected. We see them not as they are now, but as they were, bright and young and full of fire. Each photon is a quiet handshake across a gulf that will never close. Each one travelled billions of years, riding the growth of space like a leaf on an ever-widening river, slipping between galaxies through interstellar dust, past quasars and black holes, arriving finally at the eye of a telescope or the back of your retina. And then there are the galaxies that have already crossed the final boundary. Galaxies we saw once, long ago, whose light no longer reaches us. They are past the point of no return, past the cosmic event horizon, a boundary not of space, but of fate. No new signal from them will ever arrive. Their stories are finished, at least in our chapter of the universe. We caught a glimpse of their opening lines. The rest of the pages are lost to us, even as they continue writing themselves in silence far beyond our view. But that loss isn't a reason to despair. In fact, it offers a strange kind of serenity, a knowledge that the universe is bigger than what we can grasp, that no matter how powerful our tools become, there will always be more than we can reach, and that our place in it, small, bounded but filled with light, is still worth cherishing. Even the act of saying goodbye can be beautiful, because a goodbye implies a moment of connection, a shared presence, however fleeting. The galaxies beyond our grasp were once near enough to touch us with light, and that light still floats here, around us, through us. It glows in the lenses of telescopes, in the faint background radiation, in the quiet hum of detectors pointed toward the void. So when you look up at the sky tonight, know that much of what you see is already gone, and that much of what's still out there will never arrive. But also know this, in that gap between what was and what will never be, there is wonder, there is room for dreaming, there is stillness and soft motion, and a farewell that isn't sad, but sacred. The galaxies are not gone, they're just walking quietly out of view. Whenever you look up at the stars, you're not seeing the present. Not really. You're seeing echoes, impressions. Light that began its journey long before your eyes ever opened to receive it. Even the closest stars are caught in delay. Cosmic postcards sent years ago, just now arriving at your doorstep. And the farther you look, the deeper into the past you fall. This is one of the quiet, beautiful truths of the universe. To look outward is to look backward. The night sky is not a photograph of the now. It is a layered time machine, soft, luminous, and ancient. And each step into deeper space is a step into older stories, ones that began long before Earth had oceans, before trees breathed, before minds formed questions. It all comes down to the speed of light. Fast as it is, about 300,000 kilometers per second, it's not instant. It takes time for light to cross distance. A beam of light from the moon, for example, takes a little over a second to reach your eyes. From the sun, about 8 minutes, which means that every sunrise is a memory. Every solar flare, every golden morning glow is a scene from 8 minutes ago, lighting your present from the past. The nearest star beyond our solar system is Proxima Centauri, a little over 4 light years away. If it were to vanish this moment, disappear into nothingness, we wouldn't know for 4 years. We would go on watching it twinkle, unaware that we are seeing only its final echoes. This delay becomes more profound the farther we reach. Galaxies a billion light years away are seen as they were a billion years ago. The deeper we look, the further into the universe's past we peer, and our telescopes, those great glassy time machines, allow us to piece together a cosmic scrapbook made not of photographs, but of travelling light. You might imagine a room filled with mirrors, each one angled just right to reflect your image back after a different amount of delay. One mirror shows you as you were a second ago, another 10 minutes ago, another 10 years. This is what our sky is. Not a picture, but a tapestry of delay, of layered history woven across the black. And if we follow this light far enough, it leads us to something extraordinary. A boundary, not of space, but of sight. The oldest light we can possibly observe is called the cosmic microwave background, or CMB. It's not from a star or a galaxy. It's not the glow of something burning. It is the echo of the very young universe itself. Roughly 13.8 billion years ago, the universe was hot, dense, and filled with a brilliant, blinding plasma. Light couldn't travel far. It was constantly bouncing off particles in an opaque fog. But then something changed. The universe cooled, atoms formed, and suddenly light could move freely. That moment, about 380,000 years after the Big Bang, is when the cosmic microwave background was born. A soft glow, released all at once, now stretched and cooled by billions of years of expansion. Today, it reaches us not as visible light, but as a faint microwave signal, uniform, ancient, and incredibly revealing. When we map the CMB, we are seeing the first light that could ever travel across space. The earliest image of the cosmos, not in high resolution, not in brilliant colour, but in gentle temperature differences, tiny variations like ripples in still water that would eventually become galaxies, stars, and everything we know. In a way, this ancient light is the universe's baby picture, a portrait of its earliest whisperings, before complexity, before structure, before time had grown into all its branching pathways. And because this light comes from every direction, it forms a kind of glowing shell around us. We are always at the centre of it, not because we're special, but because every observer, no matter where they are, sees the CMB surrounding them. The universe, from any vantage point, cradles its own memory like a soft cocoon of time. The farther our telescopes reach, the earlier the light they catch. And so our greatest instruments, like the Hubble Space Telescope and now the James Webb, aren't just looking at distance, they're sifting through layers of history, capturing the flickers of stars that lived and died before our sun was even born, finding galaxies forming when the universe was still young, still messy, still figuring out how to be what it would become. And every discovery we make this way reminds us that space is not just a landscape. It is a timeline, stretched across silence, a museum filled not with sculptures and oil paintings, but with light. Light that has travelled across centuries and eons, arriving finally and quietly into the open hands of those curious enough to wait for it. This is what makes astronomy different from any other science. You don't just study what is, you study what was. You chase ghosts made of photons. You gather the past, not by digging into soil, but by watching the sky long enough to see what it left behind. It's a practice of patience, of reverence, of understanding that even the smallest flicker of light might contain the story of a world, that the dimmest galaxy might be a survivor from the universe's childhood, still sending out its light, even as its stars burn out one by one. And perhaps that's the quiet gift in all of this, in knowing that when you gaze at the sky, you are never looking at the present. You are bathing in memory. You are walking among echoes. You are drifting through a library where every book is made of light and every page is still on its way to being turned. So tonight, as you close your eyes, imagine this. Above you, beyond you, around you, light is still travelling, still arriving, still whispering stories from times and places you will never see, and still miraculously reaching you, right here, right now, in this small and quiet moment. If space can stretch and bend and ripple quietly around stars, then we might be tempted to ask, what shape does it all take? Not the shape of galaxies or clusters, not the twisting arms of spiral stars, but space itself, its grand geometry, its quiet architecture. Is it flat like a calm lake, curved like the surface of a sphere, or something stranger still? To even begin asking that, we need to gently return to the idea of geometry, not the kind with rulers and compasses and schoolroom diagrams, but something softer, something cosmic. The geometry of the universe is not about measuring walls or drawing neat angles. It's about how space behaves when you move through it, how lines act, how distances feel, how the structure beneath your feet, beneath everything, subtly tells matter and light what's possible. There are, in simple terms, three main ways the universe might be shaped. The first is flat. Not flat like a pancake, but flat in a more abstract sense. In a flat universe, the rules of traditional Euclidean geometry hold. Parallel lines stay parallel forever. The angles of a triangle always add up to exactly 180 degrees, and if you shine a laser in a straight line, it will keep going forever, without curving or looping back. A flat universe could be infinite, stretching endlessly in every direction without ever folding over on itself. But it could also be finite in the way a video game world is, looping softly perhaps, or wrapped in hidden symmetry. Still, the key idea is that space behaves normally, at least what we've come to know as normal in geometry class. The second possibility is spherical, or, more precisely, positively curved. In this universe, space wraps around itself like the surface of a ball. Parallel lines eventually meet. Triangles have more than 180 degrees, and if you kept moving forward in a straight line, you might one day return to where you started, having circled the universe without ever turning around. It would be finite, but without an edge. No cliff to fall from, no wall to crash into. Just a smooth, closed surface, curved through dimensions we can't directly see. The third option is hyperbolic, or negatively curved. Imagine a saddle, or a Pringle chip, or the flared edge of a trumpet. In this geometry, parallel lines diverge. Triangles have angles that add up to less than 180 degrees. Space stretches and stretches, growing wider as you go, opening into a kind of infinite sprawl. An open universe, without loops or folds, but infinite not by repetition, just by continual unfolding. Each of these shapes carries with it a different vision of what the cosmos is, and how it might have begun, or end. But how do we know what shape our universe takes? We can't fly out into space with a giant ruler. We can't walk its perimeter or look down on it from above. But we can look at the light, ancient, patient, and full of clues. In particular, scientists have turned to the cosmic microwave background, the oldest light in the universe. That soft afterglow from the Big Bang isn't just beautiful, it's rich with information. The tiny temperature fluctuations in the CMB, barely perceptible ripples in the smoothness of space, contain hints about the universe's overall shape. If space were curved significantly, those patterns would appear subtly distorted. But when astronomers measured the CMB with satellites like WMAP and Planck, they found something quietly remarkable. The data told a simple story. The universe is very nearly flat. Not perfectly flat. Perfection rarely survives the scrutiny of observation, but so close that, on scales we can measure, space behaves as if it were flat. Light travels in straight lines. The angles of large cosmic triangles add up just right. The overall curvature is so small that if the universe were curved, its radius would have to be much larger than what we can observe, so large that it might as well be infinite from our point of view. But flat doesn't mean dull. Flat space still breathes, it still grows, it still hums with expansion and mystery, and it may still hold gentle surprises, loops, warps, symmetries we haven't yet seen. After all, we're only peeking at a small part of a much greater tapestry. And here's where the metaphors come in. Imagine you are walking through a vast forest. You take step after step, always in a straight line, never turning. If the world were truly infinite, you'd never reach an end. But if it were curved, if the earth wrapped back on itself, you might find, after many long years of walking, that you return to where you began, coming full circle not because you turned, but because the world did. That's the essence of curvature. A flat universe, you walk forever and never return. A closed one, you walk forever and come home again. An open one, you walk, and the road just keeps growing wider, like the sky above a plain with no horizon. Right now, the evidence favours flatness, but it's a flatness stretched over a space so vast we can only observe a small patch, like trying to guess the shape of the Earth by standing in your backyard. It feels flat beneath your feet, it looks flat across the fields, but walk far enough and the curve might reveal itself, not abruptly, but gently, patiently, over distance and time. And so we wonder. We wonder whether the universe loops, whether it bends, whether it stretches forever or folds softly into itself. We may never know for certain. But the question, the act of asking it, the image of a traveller walking forever and maybe, just maybe, returning to their beginning, is a kind of poetry in itself, a geometry of longing, a straight line that might after all be a circle in disguise. Imagine walking across a landscape with no end. You pick a direction, any direction, and begin. The ground stretches ahead in a smooth, unbroken path. You pass trees, hills, clouds shifting above. You walk for days, then weeks, then years. At no point do you reach a wall. No signs warn that you've gone too far. There are no fences, no cliffs, no boundary lines. And then, after some unfathomable distance, you begin to notice the landscape looks familiar. Not déjà vu, not memory, just repetition. The same hill, the same tree, the same crooked rock, slanted slightly to the left, and slowly, softly, you realise you've returned to where you began. And yet, you never turned around, you never changed direction, you only kept walking forward. This is the quiet, beautiful idea of a space that is finite, but unbounded. It's a phrase that seems like a contradiction at first. Finite suggests something limited, something with a size, a shape, a measurable extent. Unbounded sounds like the opposite, endless, without limits. But in the strange, soft geometry of the universe, these two ideas can live side by side, like moonlight and shadow, part of the same dance. Let's start small. Think again of the surface of the Earth. It's a two-dimensional surface wrapped in three-dimensional space. If you're a small creature living only on that surface, say an ant, you experience your world as having two dimensions. You can walk forward, backward, left, right, but not up or down in the same way we can. For that ant, Earth's surface is a finite place. You could, in theory, measure its total surface area, but also unbounded, because you can walk forever without ever falling off the edge. That's the essence of what physicists mean when they say the universe could be finite but unbounded. They imagine our three-dimensional space might be curved, not in the usual way we experience with hills or valleys, but in a more abstract fourth spatial dimension, one we cannot perceive directly. In that vision, the universe loops back on itself, not visibly, but topologically. Just as the Earth curves in three-dimensional space, the universe might curve in four. This doesn't mean we live inside a bubble in space. It means space is the bubble, not surrounded by anything, not sitting in something else, just curving softly, quietly, on its own terms. To us, walking through such a space would feel ordinary. Straight lines would feel straight. Angles would behave the way we expect. But if we could somehow trace our path for billions of years, if we could send a light beam out and wait long enough, we might find that it eventually returns from behind us, having looped around the entire cosmos. It's a strange thought, that you could look forward and given enough time and distance see the back of your own head, if not literally, then at least metaphorically, that the universe might be self-containing, a world with no edge, because it holds itself. And if that's true, then the question, what's beyond the universe, loses meaning. Because there is no beyond. There's only more of the same, looping gently in ways we can't see. This isn't just poetic speculation. It's consistent with what we observe, at least so far. The curvature of space, measured through the cosmic microwave background, and the distribution of galaxies, appears very close to zero. That suggests a flat geometry, but doesn't rule out a very gently curved, finite space. It's like standing on a giant balloon so large that the curve feels like flat ground. You wouldn't notice the difference without travelling impossibly far. There are models, mathematical and physical, that describe this possibility in more detail. One is the idea of a three-sphere, a shape similar to the surface of a regular sphere, but existing in four-dimensional space. Just as a sphere's surface is a two-dimensional space wrapped into three, a three-sphere is a three-dimensional space curved into a fourth. In this model, the universe is both complete and without edge. Still, these are hard shapes to picture. Our minds are tuned to landscapes, to maps, to rooms with corners and walls. We instinctively look for edges, places where things stop. But the cosmos doesn't owe us the comfort of borders. It may be softer than that, gentler, a place that loops not in space alone, but in meaning. You might wonder, if the universe loops, could we ever travel around it? Could we send a probe or a signal and wait for it to return, carrying news from the other side of everything? In principle, yes. In practice, number. The distances are too vast. The universe is expanding too quickly. Even if space loops, the fabric is stretching faster than any signal could close the circuit. The loop may be there, but it may be forever unreachable. And yet, the thought that it could be, that we might live in a world so perfectly folded that it contains itself, is strangely peaceful, like living in a book where the last page leads back to the first. Not in a cycle that traps you, but in a completeness that holds you. A home, not made of edges, but of returns. So the next time you look up and wonder how far space goes, you might also wonder how it folds, whether a line you draw softly and forever might one day circle back, whether the stars you see are only a chapter, or a chorus in a song that sings itself into its own echo. Finite, yet unbounded. Not small, but held. Not limited, but whole. Now that we've gently explored the idea of a universe that could be finite but unbounded, a looping space without edges, complete within itself, it's time to step even farther from what feels familiar. We're going to venture into realms where space might not just curve, but exist as a kind of surface, a shadow, of something even greater. Not just more space, but more dimension. Not just structure, but something that quietly holds structure from behind the scenes. This is where imagination stretches like soft fabric, and where speculation, science, and wonder begin to blur into one. Let's begin with something called brain cosmology. The name comes from the word membrane, shortened to brain, and it's part of a class of ideas from string theory and higher dimensional physics. In this view, our entire universe, everything we can see, touch and measure, might be a three-dimensional brain floating in a higher dimensional space, often called the bulk. You can think of it like this. Imagine a sheet of paper. Now imagine drawing a small two-dimensional character. Let's call them Dot on that sheet. Dot lives entirely in two dimensions. They can move left and right, forward and backward, but not up and down. The world for them is flat and complete. Now imagine you, holding the paper, lifting it through the air. To Dot, that third dimension is invisible. They might not even suspect it exists, but the paper, their world, is moving in a space they cannot perceive. In brain cosmology, we might be like Dot. We live on a three-dimensional sheet of space, but that sheet might be moving, bending, or even brushing up against other brains in a higher dimensional bulk. We wouldn't see that movement directly. We wouldn't feel the higher dimension. But its presence could influence our world in subtle ways, perhaps even explaining mysteries like dark matter or gravity's strange weakness compared to other forces. And if that's true, then the universe might have an edge, of a kind, but not in a direction we can travel. Not at the end of a road or the far side of a galaxy, but in a direction that lies sideways to everything we know. A fourth, fifth, or sixth spatial axis, folded invisibly beside us. It's a mind-bending idea, and one that even physicists approach with caution, not because it's impossible, but because it lies so far beyond our direct experience. Still, mathematics allows us to describe it, and sometimes the math seems to whisper that space may be only part of a larger structure, one we're only beginning to glimpse. Then there's another idea, just as strange and just as beautiful, the holographic principle. This principle suggests that all the information in a three-dimensional region of space, the position of every atom, the curve of every photon, the weight of every gravitational wave, could be entirely described by information stored on a two-dimensional surface surrounding it. In other words, the universe we experience as three-dimensional might be a projection, like a hologram, of data encoded on a kind of cosmic boundary. It's like watching a movie on a screen. The characters move in depth. They run into the distance. They jump and fall and spin in a space that seems real. But it all comes from a flat sheet of pixels. The illusion of depth, built from layers of encoded light. If the holographic principle is true, then space might not be what it seems at all. What we take as volume, extension, and motion could be the shadows of information, like dreams playing on a page, unaware that the page itself contains the story. This doesn't mean the universe is fake, or that we live in a simulation. Rather, it means that space, and perhaps even time, might emerge from something more fundamental. Not stuff, but relationships, patterns, logic, etched on a surface we cannot reach. Where does this leave our sense of shape, of edge, of boundary? Perhaps nowhere, or perhaps exactly where we've always been, inside a mystery, a soft and unfolding shape that resists being held. We think of dimensions as paths we can walk, but maybe they are possibilities we can only imagine. If the universe is a brain, it might be drifting in a sea of other universes, brushing past others like ships in a fog. If it is a hologram, it might be the ripple of something deeper, something that holds space the way a thought holds a memory, and perhaps we will never see those higher dimensions directly. But that doesn't mean we are cut off from them. A shadow does not know the shape of the thing that casts it, but it carries the imprint, the trace, the outline. So perhaps our universe, in all its beauty, its stars and dust and galaxies curling like ocean foam, is a shadow with depth, a whisper of a deeper fabric, a note in a chord we cannot hear fully, but one that still resonates through us. And maybe, just maybe that's enough. To be part of a shadow that breathes, to be shaped by a dimension we can't name, to live in a space that holds more than space. If you could step outside the universe and look back, not from a place of distance, but from one of scale, you wouldn't see a smooth spread of stars scattered randomly across the dark. Instead, what you'd find is something far more intricate, a delicate, sprawling structure, a lacework stitched across unimaginable distances, thin glowing threads connecting luminous knots with vast dark hollows in between. This is not a poetic metaphor. It is quite literally what our deepest observations reveal. The universe is woven into a cosmic web. At first glance, the stars above might feel like pinpricks on a curtain, uniform, distant, indifferent. But zoom out, past the solar systems, past the local groups, past even the clusters of galaxies, and you begin to see a pattern emerging. Galaxies are not flung across space like sand from a careless hand. They gather, they thread, they weave. This web is composed of filaments, long strands where galaxies cluster together in gentle chains. These filaments form the highways of the cosmos, the places where gravity and matter have pooled most efficiently since the earliest moments of the universe. Where filaments intersect, you find nodes, regions of intense density where hundreds or thousands of galaxies swirl together in massive clusters. Between the filaments are voids, enormous, empty expanses of space, some hundreds of millions of light years wide where few galaxies roam. These voids are not just large, they are startlingly quiet like the still surface of a lake untouched by wind. The whole thing, when rendered in simulations or revealed by surveys like the Sloan Digital Sky Survey, looks like something organic. A sponge, a web of dew-covered silk, a cross-section of coral. It does not feel mechanical or cold. It feels alive, in the way a forest feels alive, not because it breathes, but because it moves and holds memory. This structure didn't happen by accident. It's the product of gravity, working in patient collaboration with dark matter, a kind of invisible scaffolding that makes up most of the universe's mass. Though we cannot see dark matter directly, we know it must be there because of how galaxies move, how clusters hold together, and how light bends as it passes nearby. It is as if something unseen shaped the universe with invisible hands, guiding matter into strands, compressing space like clay into form. After the Big Bang, the universe was nearly smooth, a warm, dense soup of particles expanding rapidly. But tiny imperfections, minute fluctuations in density acted as seeds. Over billions of years, gravity amplified those seeds. Where there was a little more matter, it pulled in more still. Eventually stars formed, then galaxies, then chains of galaxies. The soft creases in the fabric became the threads of the cosmic web. One of the most beautiful truths about this web is that it has no centre. Despite its complexity, there is no privileged point, no cosmic capital. The universe does not spread out from a central throne, nor spiral around a hidden axis. Every part of the web is equally valid. Wherever you are in the universe, the structure around you appears statistically the same. This lack of a centre is not an oversight. It's a kind of humility written into the fabric of existence. In ancient times, people assumed the Earth was the centre of the cosmos. Later, we placed the Sun at the centre, then the galaxy, then perhaps our local cluster. But the truth is softer and more profound. There is no centre. Every point is the centre of its own visible sphere, and none holds a higher place. That means the Earth, for all its beauty and life, is not in a special location. And yet, that doesn't make us less. It means we are part of something shared. Part of a pattern that echoes across billions of light years, drawn by forces we can feel but cannot touch. We are nodes on the thread, drops on the string, glowing moments in a much larger dance. Even our Milky Way is part of this web. It belongs to a small cluster of galaxies called the Local Group, which is itself a tiny part of the Laniakea supercluster, a name that means immeasurable heaven. And this supercluster is just one node among thousands, stretching across the sky in graceful loops and arcs. The more we look, the more we find that this web extends farther than our instruments can currently reach. And every time we map a new part of it, it fits. The same strands, the same voids, the same quiet order, repeating like music played in deeper and deeper octaves. But if there's no centre, if every part is equally distant, equally central, what does it mean to be anywhere at all? It means that meaning does not come from position. It comes from connection, from the way threads cross, from the way the invisible holds the visible in place. The cosmos does not privilege one location over another, and that means you, here, now, are as valid a centre as any galaxy. You do not live on the edge of the universe. You live inside its structure. You're stitched into its geometry, not as a mistake or an afterthought, but as one small shimmer on the thread. And just like the galaxies, you are not alone. You are connected by light, by gravity, by time. The cosmic web may be vast, but it is not empty. It holds everything, quietly, elegantly, and perhaps, if we listen closely, we can hear its shape, not as a sound, but as a stillness. A pause between questions, a breath held by the stars. If the universe is shaped like a vast web, delicately laced with filaments and voids, it may be tempting to imagine that this is all there is, just one enormous continuous structure. But some theories suggest something even more curious and even more difficult to fully grasp, that our universe may be just one patch, one bubble in a larger quilt of realities, that beyond the cosmic web we see, there may be other webs, other bubbles, stitched together not by gravity or light, but by the strange mathematics of early cosmic inflation. Let's begin gently. After the Big Bang, the universe expanded rapidly, not just expanded, but exploded outward in an almost incomprehensibly fast event called cosmic inflation. This didn't happen in space, it was space, every point stretching away from every other point. But this inflation didn't necessarily occur in the same way everywhere. In some versions of the theory, space expanded unevenly. Some regions stopped inflating sooner than others. Some pockets of space cooled down, slowed down, and formed universes like ours. Others may have kept inflating, or evolved differently. In these models, what we call the universe might be just one pocket in a much larger whole. A vast foamy expanse of bubble universes, each one sealed off by the physics that formed it. Each bubble might have its own rules, its own particles, its own version of gravity. And the edges between them, where one bubble ends and another begins, are called domain walls. These walls aren't made of stone or metal or anything we'd recognise. They're boundaries in field values, transitions between regions with different vacuum states. They are in essence seams in reality. Our universe might be one such bubble, not floating in empty space but nestled among countless others, and though we may never see the others directly, their possibility offers a quiet kind of awe. What would it mean to be inside a bubble? Well, it might not feel like anything unusual. You'd still see galaxies, still breathe air, still live your life grounded by familiar physics. The bubble is not a container. It's a state, a settled field. a region where reality has cooled into something stable. But beyond the edge, if such an edge could be crossed, everything might change. Constants we take for granted, like the speed of light or the strength of gravity, could shift. Atoms might behave differently. Time might curve in unfamiliar ways. It's like living in a valley surrounded by fog-shrouded mountains. You know the valley well, the shape of the hills, the bend of the rivers. But what lies beyond the peaks? Other valleys? Other rules? Maybe even other colours to the light? Of course, all of this is speculative. We haven't detected any domain walls. We haven't glimpsed other bubbles. The idea of a multiverse remains one of the most intriguing and most debated possibilities in modern cosmology. But speculation is not the same as fiction. These ideas arise not from dreams alone, but from real equations, real models, real attempts to understand why our universe looks the way it does. For example, some physicists ask, why are the laws of physics just so, not too strong, not too weak, not too chaotic for life? Why does the universe seem finely tuned, almost suspiciously hospitable to stars and chemistry and minds? One answer is that it's not special. We're just in one bubble that happened to be right. Not because it was chosen, but because in a vast sea of possibility someone had to be here to notice. If that's true, then we're not the centre of existence. We're a ripple, a region, a quiet bubble floating in an unseen ocean. And what of the domain walls themselves? In some models, these boundaries could exist within a universe, separating zones with different vacuum states like frozen lakes forming in separate patches. Where they meet, the ice is uneven, a crack, a seam. The temperature changed too quickly, or the conditions were not the same. Likewise, domain walls in space would be places where the universe failed to settle evenly. They might drift, they might collide, they might leave imprints, faint gravitational signatures or subtle shifts in particle behaviour. Could we ever reach one? Probably not. If such a wall lies beyond our observable universe, then its light, like the galaxies beyond goodbye, will never reach us. The expansion of space pushes everything farther away. But in our models, we can still play. We can still ask, what would such a wall feel like if you could walk toward it? Perhaps it wouldn't be a crash or a blast, but a transition. A soft strangeness in the air, colours fading, gravity shifting underfoot. A place where time slows, not because of mass, but because of change. A fog that thickens not from weather, but from uncertainty. A whisper that something fundamental is different. And maybe that's the power of this idea. Not that we will find such a wall, but that we can imagine it. That we can build pictures in our minds of a cosmos far wider, far stranger than what lies in front of our telescopes. That we are willing to wonder, even when answers are far away. Domain walls may never cross our sky. Bubble universes may never cast their light into our night. But the very fact that we can think of them, that we can model them, describe them, sketch their shadows on a chalkboard, means that they are part of our story. Not because we see them, but because we ask about them. And maybe, in the end, that's what makes space so infinite. Not its size, but its suggestiveness. The way it keeps offering more than we can hold. The way it invites not just measurement, but imagination. A multiverse may not be something we can walk through, but it may be something we're already dreaming in. Let's imagine a quiet road, stretching forward beneath a sky filled with soft stars. There is no traffic, no signposts, no wind. Just your footsteps, one after the other, echoing faintly as you walk. Path doesn't curve, it doesn't climb. It simply continues, forward, forward, into a darkness that grows neither heavier nor deeper, only quieter. And then, perhaps, something begins to change. Not suddenly, not with drama, but subtly. Like a temperature shifting 1 degree at a time, like a sound growing too still to hear, like space itself beginning to hesitate. If there is such a thing as an edge to space, not a hard wall, not a cliff, not a chasm, but a transition, What might it feel like? We're not talking here about the edge of the observable universe. That is a limit defined by time and light, by how far photons have travelled since the beginning. That kind of edge is not out there. It's within us. It's a limit of vision, not of structure. What we're imagining now is different. It's the possibility, however theoretical, that the universe could have a boundary of nature itself, a place where physics, softly and strangely, begins to shift. No one knows what this would be like, but that's part of the invitation, to walk toward the edge in your mind. Not as a scientist with equations, but as a traveller with questions. Perhaps the first thing you'd notice is that light behaves differently. You shine a flashlight ahead and the beam bends, just slightly, more than usual. Not because of gravity, but because the fabric of space ahead holds a different tension. It's as if the road is made of a different stone. You keep walking. The stars above begin to warp, their colours changing in ways your brain doesn't quite translate. Blues that lean into green, reds that stretch into silence. You try to measure things. Time between your steps, the sound of your breath. But your watch ticks slower now, or perhaps faster. You can't be sure. Something in the rhythm has softened, as if time is no longer keeping its usual beat, but has drifted into another key. Maybe this boundary is not a sudden wall, but a fog, one that doesn't obscure your sight, but makes your thoughts feel slow, not confused, just dreamy, like the moments just before waking, or just before sleep, where clarity and softness live side by side, or perhaps it's a kind of glass, something invisible and cold standing just beyond your reach. You press your hand toward it and feel resistance. Not solid, not firm, but undeniably there. As if the rules are different on the other side. As if atoms have agreed to behave one way here and another way there. A pact written in mathematics, honoured by particles, enforced by the silent boundaries of fields. You whisper a sound. It echoes, but not back to you. It echoes sideways, curling into directions you can't perceive. You're still standing on the same path, beneath the same stars, but something is off axis, not wrong, not broken, just tilted into possibility. This is what it means to reach the speculative edge. Not a place where space stops, but where it transforms. A place where constants might change, not with violence, but with grace. Where the laws of motion might take a breath and choose a different direction. Where light and gravity and time might part ways for just a moment, letting something unfamiliar shine through. Could such a place exist? Maybe. In some inflationary models, domain walls separate regions of different vacuum states, bubbles with different physics. If you were to approach one, it's not clear what would happen. Would you bounce? Would you pass through and find yourself in a world where hydrogen no longer fuses in stars, where electrons orbit differently, where time flows not forward but outward? These aren't just science fiction questions. They're embedded in serious though speculative physics, and yet the answers are as quiet as they are unknowable. Because even if such an edge exists, it's likely too far away to reach. If it lies beyond the observable universe, we will never see it. Not because we're blind, but because space itself is stretching faster than light can carry its secrets. The road ahead is not blocked, but always receding. So the edge becomes a kind of metaphor, not a destination, but a threshold of imagination, a soft border in our thinking, where what we know dissolves into what we can dream, and in that dreaming we build pictures, not of what is, but of what might be, a cosmos not with a hard edge, but a quiet shimmer, a place that does not end, but changes character. And maybe that's the most comforting idea of all. That space doesn't need to stop, it only needs to shift. That what we call the edge might not be a curtain or a line, but a gentle blur, a feathering out, like the edge of mist on a still morning lake, like the boundary between day and dusk, like the moment between one thought ending and the next beginning. So if you ever feel small in the face of the universe, remember this. The universe itself might be full of uncrossed whispers, places where reality has changed softly, just beyond the reach of light. And even if we never touch them, we are part of the same fabric, part of the same dream, part of the same question. Not trapped inside a wall, but standing at the edge of knowing, forever leaning forward. Close your eyes for a moment and picture a bath filled with foam. Each bubble drifts in soft proximity to the next, some large, some small, some still forming while others quietly fade. Each is sealed, self-contained, yet part of the same expanding froth. Now replace the bathwater with space. Replace the foam with entire universes, and let your mind drift into one of the most quietly profound ideas in cosmology: eternal inflation. Long ago, our universe was smaller than a grain of sand. It wasn't filled with stars or atoms or even light. It was filled with energy, a dense, high-pressure vacuum of potential. And then something changed. That potential began to release. Space itself began to expand, and not gradually but explosively. This moment, cosmic inflation, did not happen in space. It was space. Space growing, multiplying, stretching faster than light, fueled by the vacuum's decay. But according to some theories, this inflation didn't stop everywhere at once. In fact, it may never have stopped altogether. Instead, some regions slowed down, cooling into pockets of what we call normal space, regions like our own, while others kept inflating, still birthing new bubbles, still unfolding new universes. This is eternal inflation, an ever-growing sea of space, with isolated pockets where conditions stabilize. Each pocket becomes its own universe. Each has its own Big Bang, its own timeline, its own rules. Some might look like ours, with galaxies and stars and chemistry. Others might be wild and alien, filled with strange matter, unfamiliar forces, or no structure at all. Not universes we could ever visit, but ones that exist in the same overarching process, like bubbles in an infinite cosmic bath. It's a strange and beautiful idea, because it means our universe might not be alone. It might not even be rare. It could be one among countless others, all emerging from a common inflationary field, all expanding separately, never to meet, not separated by distance, but by the nature of space itself. The expansion between them is so rapid, so permanent, that no light could ever bridge the divide. Even if you travelled forever, you would never arrive, and yet the others could still be out there, floating, quiet, unknown. What would it mean to live in one bubble among many? It doesn't change what we see. Our sky is still our sky. Our laws of physics still hold, but it shifts something deeper. The sense that our universe is not the whole of everything, but one region in a larger quilt of existence. And that idea carries with it both humility and wonder. Because while we often ask why the universe has the properties it does, why it allows stars to form, why atoms hold together, why life is even possible, eternal inflation offers a softly radical answer. Maybe there are many universes, each with different properties, and we just happen to live in one where things work out. Not because it was chosen, not because it was designed, but because, in the vast foamy bath of space, some bubbles were bound to turn out just right. This isn't a statement of fact, it's a possibility born from equations, but it's a compelling one. It gives us a new lens to look through, one that's wide and reflective. Instead of asking, why is our universe just so, we can ask, what would it mean if there were others where things were just different enough to never allow stars or time or breath? And in that question lies a deeper realization. This place is rare, not in all of existence, but in what it allows. The night sky becomes not just vast, but precious. The atoms in your body, not just common matter, but a convergence of remarkable rules. You're here because this universe, this bubble, settled into just the right pattern, one where the story could unfold. Of course, these other bubbles are unreachable. Their light will never touch ours. The space between them expands faster than communication, faster than imagination. But the silence doesn't make them less real. In fact, the silence is part of the story. Just as there are stars we will never see, there may be whole realities we will never know, and that's okay. You don't need to visit another universe to wonder about it. You don't need to touch the edge of inflation to appreciate what it has made. You can sit here, quietly, within your own bubble, and feel the soft breath of possibility drift across your thoughts. Maybe one day, physics will find ways to test these ideas. Tiny imprints in the cosmic microwave background, subtle anomalies in gravitational waves, echoes of collisions between bubbles, written faintly in the geometry of our own sky. Or maybe not. Maybe it will always remain a soft boundary, an edge of thought rather than measurement. A shimmer in the bath where light cannot go but the mind can float. And in that floating, we discover something delicate. Not that we are small, but that we are one among many, one bubble in a vast and silent sea, and that even if we never touch another, it is enough to know that the foam continues, that creation, once begun, did not end with us, that the universe was not the final word, but one sentence in a book still being written, a quiet chapter, held between the pages of an eternal unfolding. Let's step into a quieter kind of multiverse now, not one made of expanding bubbles and eternal inflation, but one that lives closer to home, closer to you. Imagine for a moment that every choice you've ever made, every fork in the road, every yes or no, every hesitation, led not just to one future, but to two. One where you went left, and another where you went right. One where you took the job, and one where you didn't. One where you said the thing you were afraid to say, and one where you held your tongue. Not metaphorically, but physically. Real branches of reality, each unfolding in parallel, each unaware of the others. This is the soft, strange idea behind the quantum multiverse. At its heart lies quantum mechanics, the science of the very small, where particles exist not as little dots but as probabilities. In this world, things don't happen in clear steps. They hover, they drift. They could be one thing or another, until something forces them to choose. A photon might go left or right. An electron might spin up or down. A particle might pass through one slit or another, but until it's observed, it doesn't decide. It remains suspended between options. The classic image here is Schrödinger's cat, a famous thought experiment meant to reveal the weirdness of quantum rules. In the story, a cat is placed in a sealed box with a vial of poison, triggered by a random quantum event. Until someone opens the box and checks, the cat is not alive or dead. It is both, or neither. It is in a superposition, a blend of possibilities, unresolved. In the Copenhagen interpretation of quantum mechanics, the act of measurement collapses this cloud of possibilities into one reality. But the many worlds interpretation offers something more radical, and oddly peaceful. It says, maybe the cloud never collapses. Maybe all possibilities are real. Maybe every time a particle faces a choice, the universe branches. One branch where the cat lives, one where it dies, one where the electron spins up, one where it spins down. Each branch continues, unaware of the others, each just as real. And if quantum events can branch universes, then what about your own choices? After all, your brain is made of particles. Your neurons fire because of molecular interactions. What if each moment of decision, however small, sends a ripple through this quantum sea, spawning parallel versions of your life? It's not a question of guilt or regret. It's not meant to overwhelm. Instead, it's an invitation to imagine that for every version of you watching this video there might be others, watching different ones in different rooms with different lives. Not ghosts, not illusions, just paths, walked by versions of you that you'll never meet. Picture it as a library, not one you can enter, but one that exists nonetheless. On its shelves are books, millions of them, perhaps infinite. Each one tells your story from beginning to end. But the chapters vary. In this one, you learn to dance. In that one, you left earlier. In another, you forgave someone you hadn't yet in this life. You won't read those books, but the library might still be there. And every time you choose something, you place a new book on a new shelf. Not because you were meant to, not because you should have done otherwise, but because reality, at its deepest level, might not be a single line, but a tree endlessly growing. Now, to be clear, this is not a claim that you can visit these other selves, or that they influence your life. The branches once formed don't seem to communicate. They're like parallel rivers, each flowing in its own direction, unaware of the others. But they are still part of the same source, the same water, the same physics. Some people find this idea dizzying, others oddly comforted, because it means you're never just one version of yourself. You're the felt version, the one whose footsteps you hear and whose thoughts you carry, but you're also part of a broader possibility. You're the thread you're walking now, but also one strand in a much wider weave. And maybe that's the point, not to be paralysed by what could have been, but to honour what is, knowing that it exists among many. You don't need to read every book in the library to value the one you're living. You don't need to visit other paths to feel the weight of this one beneath your feet. You are here. That's enough. Maybe somewhere, a version of you became a scientist or a poet, or lives in a town you never visited. Maybe somewhere you said yes when you said no. Maybe somewhere you never watched this video. But this version, this quiet moment right now, is yours, and it matters. Even if you are just one leaf on the quantum tree, you are still part of the tree. You still move with its wind. You still glow with its light. And maybe the universe is not made of things or particles or points in space. Maybe it's made of paths, of unfolding, of choice. Not because every path leads somewhere grand, but because every path is something grand. You. Now. Here. What if the universe didn't just arise from physics, or particles, or even fluctuations in a quantum field, but from something simpler, something even more abstract? What if it came not from energy, but from math? Not from what exists, but from what can be described. In this final journey through the multiverse, we enter the most ethereal possibility of all, one where existence is not the exception, but the rule. One where every mathematically consistent structure is real, not imagined, not theoretical, real, in the deeper sense. This is the quiet, head-spinning idea known as the mathematical universe hypothesis, proposed by physicist Max Tegmark. It suggests that every logically self-consistent set of equations describes not just a possible world, but a real one. That our universe is just one such equation brought into being, not because it was chosen, but because it was valid. In this view, the universe is not a story being told. It is a pattern being expressed. Just as triangles exist in geometry and circles follow rules regardless of whether anyone draws them, so too might entire universes, each one a consequence of some underlying mathematical truth. If the equation holds, then the world exists, and ours, this glowing sky, this earth beneath your feet, this breath in your chest, is simply one such solution. It's a humbling idea, because it means that existence is not a rare event, but a default outcome, that the space we live in is one of countless others, each emerging from a different rule set, a different logical scaffold. Some may be familiar, others may be so strange they defy language. Universes where time loops back, where dimensions fold like lace, where consciousness arises from completely alien structures, not neurons and electricity, but something unrecognizable. But all of them exist in their own right, not in imagination, but in logic. Not because someone thought of them, but because they are true. Of course, this raises a gentle but profound question. What does it mean for something to be real? Is it enough that it can be touched, seen, measured? Or is it also real if it can be described, defined, held in thought with perfect clarity? You've never visited a 17-dimensional object. You've never seen a 6-colour photon or a space where gravity pulls sideways. But if such systems are mathematically consistent, if the rules work, even on paper, then according to this hypothesis, they're not just possible, they are. Somewhere. Not necessarily in space as we know it. Not behind the curtain of our sky, but in the vast field of mathematical being. Think of it like a library, not of stories or choices, as in the quantum multiverse, but of truths. Each shelf holds a different logic, each book a different kind of math. Some describe universes with particles, fields, and forces. Others describe strange entities or symmetries that shimmer through spaces we cannot visualize. Every page is consistent. Every page creates a world. You don't need to read them to know they're there. In this mathematical multiverse, our reality is not privileged. It is not the only one with stars or with people or with moments of wonder, but it is one we are able to feel, one whose logic supports observers like you and me, one that allows its own equations to become aware. That's a quiet miracle, not because it makes us special, but because it makes us possible. It means the very laws that shaped your body, your mind, your memories are part of a pattern that holds, a consistency that breathes, a structure that could not be otherwise, and so, here you are, alive inside an equation that happens to know itself. And what about the others? They may never touch us, never intersect. They are not out there in a place we can fly to. They are alongside, in a space without direction. They are not spatially removed, but logically distinct. A different grammar, a different language, a different song. And if this is true, if the universe is math, and math is real, then you are not a fluke. You're not a mistake. You are a proof, a line in the solution, a thread in the logic of a world that holds. Somewhere a triangle might dream of motion. Somewhere a symmetry might ripple into thought. Somewhere the equation that is you might unfold again, in a slightly different form, but still whispering something kind, something curious, something awake. And perhaps this is what makes the mathematical multiverse so gentle, even in its vastness. It doesn't erase our significance. It doesn't flatten our stories. It places us in a gallery, not of mirrors, but of meanings. Each one unique, each one held, each one true in its own light. You're not the only possible world, but you are one, and you are enough. There's something oddly comforting about a question that refuses to be answered. A question that stays just beyond reach, not because we aren't clever enough, but because its very nature stretches wider than certainty. Where does space end? You've carried this question with you since childhood, maybe without knowing. It may have arrived the first time you looked up at the stars on a clear night, or when you stared at a globe and wondered what lies beyond the edge of everything. But as we arrive at this final stretch of our journey, we must gently hold this thought. Space might not end at all, and that doesn't make it meaningless. It makes it majestic. Let's return to what we've discovered. Space, as we understand it, can be flat, closed, or open. If it's flat, then space stretches on infinitely in every direction. If it's closed, like the surface of a sphere, but in 3 dimensions, it loops back on itself, finite but without edges. If it's open, like a saddle, it may also be infinite, curving away from itself forever. In each of these shapes there's no wall, no border, no sign reading, "End of universe, please turn around." And that, strangely enough, is the answer cosmology keeps offering. Space doesn't need an edge to be complete. But here's the truth. no equation can fully convey. Even in the infinite there is texture. Even in endlessness there is structure. The universe doesn't need to end to feel shaped. And our minds, shaped as they are by beginnings and boundaries, still long to find one. So we imagine. We ask, what does it mean for something to end? Is it the absence of continuation? A cliff where nothing lies beyond? A final door that never opens? But these are ideas drawn from our limited experience, from rooms, from maps, from the stories we tell. The cosmos doesn't follow the rules of storybooks. It doesn't care for tidy conclusions. Instead, it offers us something more open and far more quiet. A horizon. A horizon isn't a wall. It isn't even a line. It's a limit of what we can see, a moving boundary that always remains just ahead, no matter how far you walk. The edge of the ocean seen from shore, the last hill before the sky swallows the land. It appears fixed, but it's an illusion of perspective. The more you move toward it, the more it moves away. The cosmic horizon is like that. It marks the limit of what light has had time to reach us since the beginning of time, roughly 46.5 billion light-years in all directions, though the universe itself is only 13.8 billion years old. Because space has been expanding all the while, galaxies that emitted their light long ago have been carried farther away. And beyond that distance, there is more universe, more galaxies, more structure. But their light will never reach us. Not because we lack the tools, but because space itself is stretching faster than light can cross it. So for us, the universe appears bounded, not by an actual wall, but by the soft limits of visibility, by the silent speed of a light and the quiet expansion of space. You might think that feels like a loss, a great cosmic unfairness, that so much of the universe lies forever hidden, unreachable. But perhaps it is a kind of mercy, a kind of beauty, to know that the cosmos is not defined by what we can measure, but by what we can imagine, that even though the horizon stays ahead, we are allowed to walk toward it, we are allowed to ask about it, to dream around it. And what if space is infinite? Then it is not something we can ever hold in our minds. Infinity is not a number or a thing you can point to. It is an idea, a direction without a destination, a shape that never closes, a breath that never ends. But maybe we don't need to picture all of it. Maybe we only need to know that it's there, stretching softly beyond every question. And if space is finite but unbounded, as some models suggest, then we return to that comforting image, walking in a straight line forever, only to find yourself circling gently home. A universe without edges, not because it's infinite, but because it folds into itself. Either way, space does not offer a simple stopping point. It offers layers, possibilities, gentle transitions, and maybe that's better than an edge. Edges divide, they separate. But the universe, as we understand it, does not divide us from what lies beyond. It includes us. It wraps around us like a quiet atmosphere of meaning. Perhaps the deepest truth is that boundaries are not always physical. Sometimes they are perceptual, psychological, poetic. The boundary of the universe may not lie out there in space, but in here, in us, in what we can see, in what we can ask, in how far our thoughts can stretch before returning, gently, like light looping through curved space. So if someone asks you where space ends, you can smile softly and say, it might not. And if they ask what lies beyond the edge, you can say, maybe the edge is an illusion. Maybe the universe is the kind of story that doesn't need a last page, just chapter after chapter written in stars folded into time. And if they ask whether that scares you, you can say no, because it means we live in a place too large to be boxed, too vast to be finished, and too beautiful to need an end. There's something quietly miraculous about not knowing. Not the kind of not knowing that comes with confusion or fear, but the kind that feels like standing in a cathedral with no ceiling, watching light filter through stained glass that you can't quite touch. The kind of not knowing that opens rather than closes, that invites instead of concludes. This is the kind of space we now inhabit. Space without edges, not because we've mapped everything, but because we've accepted that mapping may never be the point. The universe may stretch endlessly, loop softly, or even branch infinitely across dimensions we'll never see. But it doesn't need to end for it to offer meaning. And we don't need to reach a final answer to feel like we've arrived somewhere true. The question, does space ever end, has carried us through geometry and gravity, through horizons and hidden universes, through probabilities and patterns and the strange dream of mathematical existence. But here, near the close, we step away from answers. We rest not in knowledge, but in wonder. Because wonder is not a stepping stone to discovery, it is a destination of its own. You see, the scientific mind often searches for closure, evidence, results, resolution. But the human heart thrives in openness, in the mystery that glows just beyond understanding. It is in that glow that stories begin. It is in that quiet that awe is born. We often speak of pushing the frontier of knowledge, but perhaps the frontier isn't something to push at all. Perhaps it's a shoreline we walk alongside, not to conquer, but to listen to. Like waves lapping at the sand, always retreating, always returning. You're not required to know where the universe ends. You're not required to calculate the totality of existence before you can feel its beauty. You're allowed to float in the unknown, allowed to rest in the absence of boundaries, allowed to dream past the edges of even your imagination. This kind of wonder is a soft and sacred thing. It does not shout. It does not demand. It hums quietly beneath everything, beneath your thoughts, beneath the stars, beneath the steady rhythm of your breath. And sometimes, the most powerful thing we can do in science is not to solve a problem, but to ask a question in such a way that it never really ends. A question that becomes a kind of lullaby, repeated across generations, woven into the way we look up at the sky. That's what "Where does space end?" has become. Not a puzzle, a poem, not a finish line, a field, not a wall, a whisper. And here's the most curious part. This wonder we feel when we gaze into space isn't really about space at all. It's about us. It's about the fact that we can feel the distance, that we can imagine the unseen, that something inside of us resonates with the infinite, not with fear, but with longing. You've probably felt it before. Maybe when looking through a telescope for the first time. Maybe while flying over a cloud-covered Earth. Maybe when hearing the stillness between two stars in a planetarium dome. That moment where your breath catches just slightly, not from panic, but from presence. From realizing that you are small, but not insignificant. Temporary, but not irrelevant. A dot in a sea of dots, yes, but also a witness, a listener, a participant in the story that space has been whispering since the beginning. And maybe that's the only answer we need. That space, whether it ends or not, includes us. That its silence carries our curiosity. That its vastness reflects our capacity to wonder. You're not waiting for the universe to finish so you can understand it. You're understanding it simply by being here, by asking, by imagining, by walking the horizon line of your own thoughts, even when you know you'll never reach the edge. And if space has no wall, perhaps your imagination doesn't either. Perhaps there is no last idea, no final image, no point where thought must stop. Perhaps you can drift forever, not in confusion, but in contentment, in a calm kind of curiosity, in the slow unfolding of wonder that doesn't close but opens with every step, like walking through a dream that gently reshapes as you go, like reading a book whose last page always turns into another first, like living in a story that doesn't end because it doesn't need to. And that's what this is. Not a conclusion, but a continuation. A reminder that space, however it's shaped, however it behaves, has made room for you. A single mind, listening, floating, asking softly, and receiving not answers, but stars. There's a kind of quiet that only comes at the end of a long journey. Not the kind that demands silence, but the kind that feels like it has earned it. A hush that follows not from absence, but from fullness. Like the soft exhale after a deep conversation. Like the slow closing of a book that has changed you. You've walked through time and distance tonight. Not with your feet, but with your thoughts. You've wandered across invisible threads of gravity and geometry, through expanding space, shifting light, and the dream of other worlds. You've stood at the horizon of your own understanding and let it whisper to you, not in answers, but in calm, resonant wonder. And now, as you rest here at the edge, if it can even be called that, you're invited to do something far more difficult than calculation, far more powerful than curiosity. You're invited to simply let go, not of what you've learned, but of the need to hold it tightly. Not of the universe, but of the feeling that you must stay awake to belong to it. You've listened, you've imagined, and that's enough. There is no need now to grasp the structure of space-time or trace the borders of possibility. The universe is still here, still unfolding, even when your eyes close and your breath slows. You're allowed to stop wondering for a while. The stars will keep burning without your attention. The galaxies will continue their drift. The light will travel and time will stretch, and space will hum its low, eternal note, and you can sleep. This night is not small. It holds everything. It holds every question you've asked and everyone you haven't found the words for. It holds the physics of stars and the dreams of creatures who've barely stepped outside their atmosphere. It holds the tension of forces and the softness of thought. It holds you, not as something separate, but as something within. Like a ripple in a pond, a flash in a filament, a note in the great quiet music of existence. Maybe the most profound thing isn't that the universe is large. Maybe it's that it includes this moment, right here, right now, with you in it, wrapped in thought, wrapped in stillness, wrapped in a sky that does not need to end. And even if you don't feel small or grand or anything at all, maybe that's okay too. Maybe you don't need to feel a certain way. Maybe you only need to be. The atoms in your hands were forged in stars. The breath in your chest was once part of ancient oceans, part of leaves, part of lightning. And now, in this breath, in this heartbeat, you return that gift to the night. So let the thoughts fade. Let the edges blur. Let the stars you've collected tonight drift softly into your dreams. There's nothing left to do now. Nothing more to understand. You've reached the end of the question, not with a period, but with an open space. A page where you can rest. A lull between ideas. You do not need to know how far space goes. You're already in it. You are already enough. So sleep, little star walker. The universe is wide and patient and still unfolding, and even if it never ends, you can. Tonight, just rest.